Hello, my name is Keshwani. That's Keshwani, Keshwani. We are here because we want to learn algebra. Today is our day number 41. Today is our lesson number 41. Let's see what we have for today. We are learning right now how to add and subtract algebraic expressions. In the first 20 days we learned how to evaluate algebraic expression. Now we are learning how to add and subtract algebraic expressions. We'll end in 5 days. Today is day 41, so we got 5 more days to go, and we'll be done with this topic, and then we'll move on to learning how to multiply and divide algebraic expressions. And after that we're going to start the linear equations, and then we'll move on to the word problems. That's the game plan. Here's the problem for today. It says subtract x cubed minus 2x squared plus x minus 1 from 1 plus x squared plus x cubed. That is what we are told. Subtract x cubed minus 2x squared plus x minus 1 from 1 plus x squared plus x cubed. Well, two things we have to take care of. One is the fact that we are told, as I explained before in the previous video, we are told to subtract, if we are told to subtract 5 from 7, even though the problem is presented like this, subtract 5 from 7 and 7 lines up with 5, we know better that when you're subtracting 5 from 7, the 7 has to go on the top and the 5 has to go on the bottom. That way we can subtract it. That's just a standard way of doing it. That's just a convention. The same exact logic applies in algebra. The thing that you're subtracting from, the expression that you're subtracting from, has to go on the top, and the expression that is being subtracted has to go on the bottom. So that's what we have to take care of here. The second problem here is that the like terms are not lined up properly here. We got an x cubed here and x cubed there. We got a 2x squared here and x squared here. We got an x here and x there. We got a constant here and a constant here. They're not lined up properly. The top expression is written in descending order of the exponent. The bottom one is written in the ascending order of the exponent. Ascending and descending. Descending means decreasing order. Ascending means increasing order. While we are at it, even though we have done this thing already once or twice, I want to do it one more time. We're going to write down the word ascending and descending, so that we know how to spell it, or at least I know how to spell it. You might know it, being the native speaker that you are. I, on the other hand, am not. Ascend. Why don't we make a note here? This is ascending order. This is the ascending order of exponents. That's how we say it, ascending order, because it's going from, well, let's talk about it for a second. This is the 1. 1 plus x squared plus x cubed. What exponents does this guy have? Well, I'm going to digress for a second. And for those of you who still do not know what digress means, it means to go off topic, to change subject. I do that a lot. I have a very high tendency of digressing. And whenever I do digress, I always tell you that I'm digressing. And when I finished my digression, I always tell you that's the end of the digression. Back to the subject. If you're interested in learning the word digress along with some other interesting word, just like this video that you're watching right now on algebra, I also have videos on the YouTube on geometry. If you want to learn about geometry, just type in Keshwani Prep -geometry -day and whatever day that you want to put in, it will pop up if the video is there. I don't know how many days I went on geometry. I think I stopped at 30. I had to make some more. Similarly, I have videos on vocabulary. Just type in Keshwani Prep -vocab -day 60, and you will learn all the words that I covered on day number 60. I'm up to day number 63 right now. This word digress was covered on day number 3. And that turned out to be a very long digression to just to discuss the word digress. Anyway. Where was I going with this thing? Oh, ascending order of the exponent. Ah, here we are. This one, what exponents does this have? Oh, I left out something, didn't I? We have 1, we have x squared. This is a squared. What exponent does this guy have? It has an exponent of 3. What exponent does this guy have? It has an exponent of 2. What about this guy? X by itself, what exponent does it have? It has an exponent of 1. It has an exponent of 1. What about 1? What exponent of x does 1 have? Listen carefully. What exponent of x does 1 have? Sounds like a very strange, very bizarre question because there isn't any x there. Is there? Yes, there is. Watch what happens. You have to learn to think like mathematician. That's what it is. Algebra, as I told you before, in the first day of the introduction, is a language. We are here to learn a language, algebra. And you have to learn the language basically. You have to think like a mathematician. Here, technically, it was a 1, but it was a 1x to the 0. 1x to the 0. Any number raised to 0 equals 1. Make a note of it if you did not know it. X raised to 0 is 1, regardless of what x is. 5 raised to 0 is 1, 100 raised to 0 is 1, negative 1000 raised to 0 is 1, 2/3 raised to 0 is 1. Any number raised to 0 is 1. So this is 1 in fact. X raised to 0, this quantity right here, is 1. So it's just 1 times 1, which is 1. So here we have an exponent of 0. Voila. Voila. You see? We're going from 0 to 1 to 2 to 3. The exponents are going up. They are in ascending order. Here they are in the descending order, which I cannot write yet because I do not know how to spell the bloody thing. Descending, from what we learned 2 days ago, should be spelled as the prefix D, as in not, and then we do not want the A again because you will end up with 2 vowels together. So you skip the A and then the rest of the spelling is the same. Descending. One more time. Descending, D as in, the prefix D as in not, and then ascending, except we do not write the letter A because we do not want E and the A together, two vowels together. So we forget the A and it becomes descending. This is the descending order. It goes from 3 to 2 to 1 to 0. See this one again. I'm going to put it here. This one again has x raised to 0. This has x raised to 1. So it goes from 3, exponent of 3, to 2, to 1, to 0. And the bottom one is in just the reverse order. The top is in descending order, the bottom is the ascending order. This is all messed up. We have to line them up properly before we can do anything. We cannot add or subtract these expressions the way they are presented until we line up the like terms. Hence, adding and subtracting of the like terms. Trying to add x cubed to 1, they are unlike terms. They are dissimilar terms. They are not similar terms. 2x squared and x are not similar. They are dissimilar. So we have to line them up properly. I'm going to erase everything here. Just remember, any number raised to 0 is 1. Any number raised to 0 is 1. So let's line them up before we can do anything. This turned into a very long discussion. I do not know how, but that's how it is. So top one was x cubed minus 2x squared. Oh sorry, we don't write the top one. You see, I almost made a mistake. The expression where we are subtracting from has to go on the bottom, has to go on the top. This expression has to go on the top because you see, again one more time I'm going to remind you, subtract 17 from 20. 20 has to go on the top and 17 has to go on the bottom. 20 has to go on the top even though it appears later. This expression has to go on the top. So here we go, x cubed plus x squared plus x plus 1. Oh, this one was very straightforward. And now we can write the other exponent. X cubed minus 2x squared plus x minus 1. This one has a positive sign in front of it. The very first thing we need to do before we can do our subtraction is to change the sign. This positive is going to become negative. This negative is going to become positive. this positive is going to become negative, and this negative is going to become positive. And after we finish doing this problem, I'm going to do it one more time a different way to make you understand what we just did. Okay, so listen. Okay. Oh, there you go, it drops out. This is a positive x cube. This is a negative x cube. It's going to drop out. Let's do it in a different color because we have the flare for the dramatics. This drops out. Here we have x squared and a positive 2x squared. We get 3x squared. A positive x and a negative x is going to drop out. And positive 1 and a positive 1 is going to give us 2. So that's your answer. That's our final answer. 3x squared plus 2 is the final answer. Now we're going to do the same thing one more time. We're going to do the same thing one more time in a different method, with a different method. So watch what happens. Write the second expression first. X cubed plus x squared plus x plus 1. And from this expression, we're going to subtract the top one. So we're going to subtract it. You see, subtract this expression. X cubed minus 2x squared plus x minus 1. So this is just x cubed plus x squared plus x plus 1. And now what happens when we open the parenthesis? When we open the parenthesis, this has a plus sign in front of it. Positive and negative becomes negative. This becomes negative x cubed. You see, positive and negative. Positive times negative becomes negative x cubed. You see right here, negative x cubed. The positive became a negative. This negative 2x squared, when we multiply it, because of the fact that the negative sign is outside, this negative sign right here, a negative and a negative is going to become positive. It's going to become positive. Positive 2x squared. You see, a negative sign turned into positive. Right here, negative turned into a positive. And finally, when we go to this guy, a negative times a positive is going to become negative. Negative x. This positive x turns into negative x because this negative sign is being multiplied by the outside negative sign. So the positive x becomes negative x. Right here, positive x became negative x. And the negative 1, when we multiply it by the negative outside, a negative and a negative is going to become positive 1. Voila. Right here, positive 1. And now, we add them, just like we added here, we add them. So what we notice here, let me use a different color because there's going to be too much red otherwise. What we notice here is that here we have a positive x cube and here we have a negative x cube. They cancel out. And then we have 1x squared and 2x squared, so we get our 3x squared. And then we have positive x and a negative x. They're going to cancel out. And then we have 1 plus 1, we get our 2. There you go, voila. Same as before. That's how we have to do it. So the answer is 3x squared plus 2. This is one way of doing it. The top one was another way of doing it. But in both cases, all the signs have to be changed. This positive becomes a negative, this negative becomes a positive, this positive becomes a negative, and this negative becomes positive, which is exactly what we did here. Do you understand? Let me look at the time in the back. Let me take a look at the time in the back of the camera. And if I decide to go for one more problem, then I'll do one more. Otherwise, I'll have to change it one more time from 45 to 50 because I have 10 problems and I want to do all 10 of them. I was hoping to do 2 per day for the next 5 days. Let me check the time, okay? I'll be back in 1 second. No, we are done for today. I will do one problem each day because there is a lot to learn here and I don't want to rush through it. You take your time, you learn it properly, you do it once, you do it properly, and then you're done. Don't try to do it in a hurry. I'll see you tomorrow on day number 42. And if this has to be turned to 40, this 45 one more time has to be changed to 50, then so be it. Alright? We're not in a hurry. We are here to learn. We're not here to do problems. There's a difference. I'll see you tomorrow on day number 42.